Hey guys, today we're going to be looking at similar shapes and proportions. Similar shapes have the same shape but not necessarily the same size. This little symbol here means is similar to. So for example, triangle ABC is similar to triangle XYZ. Now for shapes to be similar, the measures of their corresponding angles have to be equal, and the lengths of their corresponding sides have to be proportional. For example, let's look at the angles first. So corresponding basically just means in the same position. So again, corresponding here and here just means that those angles or those sides need to be in the same position. So angle A is corresponding to angle X. Those are in the same position. Angle B is corresponding to angle Y. And then angle C is corresponding to angle Z. Same position. Those angles have to be congruent. So if angle A is 50 degrees, angle X also has to be 50 degrees. Corresponding sides have to be proportional. Now we're going to talk a little bit more about that here in just a minute, but corresponding sides, AB here is corresponding to XY. Another pair of corresponding sides might be BC here is corresponding to YZ. And then the third pair of corresponding sides would be AC is corresponding to XZ. Again, corresponding just means that they're in the same position. These sides don't have to be congruent, but they do have to be proportional. The angles have to be congruent. So down here we want to determine if the following shapes are similar, and then just keep in mind these shapes are not drawn to scale. They're not a perfect fit. So we have to check to see, are the angles congruent? And then we have to see, are the sides proportional? If we can answer yes to both of those questions, then these are similar triangles. So let's check the angles first. So let's see, I see a 54 here and a 54 here. Those are in the same position and those are congruent, so that part's good. Now I see a 49 and then I see a 77, so I'm not seeing the third angle, and we need to figure out what the third angle is. Remember, in a triangle, angles add up to 180 degrees. So we could, let's see, we know all three add up to 180, so we could do 180 and then subtract out the 49. When we subtract, that would give us 131, and then we could take that answer and then subtract out the 54. And that gives us 77 left over, so that's 77 degrees here. And look, that matches with the other 77. So these corresponding angles are congruent. Well, if we know that this is 54 and this is 77, same in this first triangle, then we know that its third angle has to be 49. So the third corresponding angles are also congruent. So far so good. The angles check out to be true. Now we've got to figure out the sides. Now just a review on corresponding sides, remember they are in the same position. So this side here is corresponding to this side here, and this bottom side here is corresponding to the bottom side here. And then that leaves the third side to be corresponding as well. These sides don't have to be congruent, but they do need to be in proportion to each other. So we're going to set up fractions, and we're going to do the larger triangle over the smaller triangle. And we're going to do that for each of the sides. So for the first set of sides, let's take the 25 from the larger, and then corresponding to 25 was yellow, which would be 10. So that would be the first fraction. The second fraction, let's take the 27.5 over the other orange, which would be 11. And then the third fraction would be the 17.5 over 7, pink in the other one. And then all we're going to do is FILO, first in, last out. So 25 goes inside, 10 goes outside. If we were to divide this out, that would give us 2.5. Okay, we do the same thing here. 27.5 in, 11 out. So if we divide, 11 goes into 27 twice, and we would subtract 22, because 2 times 11 is 22. With 5 left over, bring your decimal up, bring down the 5, and if you notice, 11 goes into 55 5 times. So far, both of these give us the same number, so those two sides are proportional to each other. Then we're going to check this third one. 17.5 in and 7 out. 7 goes into 17 twice. 7 times 2 is 14. When we subtract, 3 left over, bring up the decimal and bring down the 5. 7 goes into 35 5 times. So if you notice, we got 2.5 each time. So that means that these sides are proportional. So the sides do check out. Since we can say yes to both of these things, then yes, these shapes are similar. Alright, let's check the next two and decide, are these similar or not similar? So remember, we have to check the sides and we have to check the angles. Now, if you can remember, when there's a little box in the corner, so like here, here, these angles are called right angles. And right angles are all 90 degrees. So since all of these are labeled with a 90-degree angle, we know that the angles are congruent. They're all 90. They're all the same. Okay, so the angles check out. And then we got to decide, are the sides proportional? So we're going to set up our fractions again. Let's do larger over smaller again. The larger would be 7.2 here over the corresponding side. Let's see. So 7.2 is the up and down side, and this up and down side is corresponding to this 3. And then the other pair would be this 12 along the bottom is corresponding with this 33.6. So 7.2 corresponds with 3, and then 33.6 corresponds with 12. We have our fractions. Now we're just going to do FILO, first number in, last number out. So 7.2 in, 3 out. 3 goes into 7 twice. 3 times 2 is 6, so we're going to subtract that here. With 1 left over, bring your decimal up, and then bring down the 2, and then 3 goes into 12 4 times. So this ends up being 2.4. So we need to see, will this other one give us 2.4 also? So first number in, 33.6 inside, and then 12 outside. 12 goes into 33, 2 times, minus 24 would be 9. Bring up the decimal, bring down the 6. And I'm just going to say now that 12 does go into 96, and that would be 8 times. 12 times 8 is exactly 96. So if you notice, these two numbers here are not the same. So the sides are not proportional, so these are not similar. So when we divide, we have to get the same number each time for it to be proportional, just like what we did with tables here a while back. Alright, let's look at the last one here. It says quadrilateral JKLM is similar to the quadrilateral QRST. And then we've got to decide which of these statements is true. Alright, let's look at this first one here. It says JKST is equal to JLRT. So we've got to decide, are these sides in the same position? So let's start highlighting JK and ST. Now if you notice, one's on top and one's on bottom. However, if you look at the quadrilaterals, it looks like it's flipped upside down. Like this corner Q looks like it would match this corner L. So we have to visualize how it is flipped upside down. So since it's upside down, JK is upside down from ST. So that part works out. Now JL, I'm going to get a different color highlighter. JL, back to the smaller shape, and RT. Let's see. So this one's on a diagonal part, and this one's on the up and down part. So those do not match up. So letter A is false. Okay, let's look at B. So angle JKM is congruent to QRT. So let's find JKM. So JKM, that would be this angle right here, is congruent to QRT. So from QRT here. So let's compare those two angles. Now remember, it's flipped upside down, so this top angle would actually be upside down to this bottom angle here. Those are not in the same position, so those don't have to be congruent. So we'll call this one false. Alright, let's look at LMK. So LMK here is congruent to QST. So QST here. Well, LMK, this bottom angle, does not have to be congruent to this angle here, because those are not in the same position. They're not even on the same side, because all that happened was the shape got flipped upside down, and so it's not even on the same side. So this one is also going to be false, which means this last one should be true. So we're going to try it out. I'm going to get different highlighters. Alright, LM is located at the bottom, and KM. So if you notice, I just highlighted two sides that are in the same shape. So this part works out pretty good. So now we got to see, is LM in the same position as QR? So let's look at QR here, and RT. So LM was this longer side across the bottom. Remember, it was flipped upside down. So this is the longer side across the top, upside down as well. And then RT was up and down along with the KM. So this one is true. Everything matches up exactly. Alright guys, remember there are two qualifications for similar shapes that we need to remember. We need to remember that the corresponding angles are equal to each other, and then the corresponding sides are proportional. They don't have to be equal, but when you divide, they have to give us the same answer. Thank you guys for watching.